to introduce themselves to our learners. I'm happy. The numbers are trooping in. I think people are leaving classes and coming to join the session. So Gareth, over to you.
Thank you so much, Terence and Eric and everyone. As Terence says, it's always a pleasure chatting to yourselves and the learners and stuff. And yeah, always happy to put back an assist for all the hard work that Terence and team do. So from my side, as Terence indicated, and for those that maybe have joined previous sessions, my name's Gareth Bowers. I'm CEO of Silicon Overdrive. I'm software developer by background, as well as an AWS solution architect. And yeah, so I wear a few hats. I chat to a lot of clients. I do quite a few of the well-architected reviews, which is an AWS framework structure. So yeah, I think the topic for today that we will be looking at is cloud native application security and building and deploying secure applications in the cloud. So it's a great topic, and it can be quite a nice broad ranging set of concepts. So I've kept it very top level for this session. So yeah, I think there's a lot to be learnt or a lot to cover just in terms of the concepts and stuff. So I'm super excited to share a bit from the top level. I see there's still a lot of people joining, so let's maybe just wait another minute.
Over to you, Gareth.
Cool. Thanks, guys. So what I've done is I've basically tried to break it down into logical kind of things from my side, but obviously there's an awful lot that can be looked at discussing around cloud native applications and security and stuff. So I've tried to keep it into a bit more simple top level concepts, and then if based on the feedback on here, I can maybe review it going forward, and we can see where maybe there's a bit more interest in this various sections and stuff. So firstly, I'd like to just touch on what we sort of covered in the last session, which is the shared responsibility model. Whoopsie. So we did cover that in the last session. I just want to touch on this briefly because this really comes back to the heart of what is expected from the system admin, what is expected from the developer. So AWS or any sort of cloud provider is going to provide their responsibility up until the hypervisor level. So whether you're running on an EC2, they will provide the hardware. Whatever operating system you put on, you need to maintain, you need to patch. If you're running a containerized workload like Docker, you need to be updating the container. You need to be updating the operating system that the container is running on. So that sort of responsibility speaks to how are you accessing it? How are you working with it? How are you deploying it? Where is that sitting? It does become your responsibility to kind of make sure that you're understanding what operating system it's running, how is it being patched, what antivirus, what sort of vulnerabilities are there, how are you deploying it, what possible attacks can there be, and kind of working out based on your tech stack, how are people thinking about trying to break it? So if you follow a lot of the attacks and the things that happen over the last year or 2 years or 3 years, you'll see that a lot of the methods of attacks change, and that's why it's important to keep up to date with a lot of the sort of the antivirus and the and firewalls and things, because they normally have managed rule sets that help take that load off you or your team, so that you don't need to constantly be kind of updating things to deal with X or Y. They will be handling it for you. So if we remember back, for those that remember a year and a half ago, there was a lot of the issues with Apache and the Log4j, issues where you could get root level access to Linux boxes if it was running Apache that wasn't patched. You'll find then that those are serious things that effectively gave somebody complete access to your box with a relatively easy method to attack it. So it's important to just be kind of understanding what components you're using in your software or in your solution, what libraries, what plugins, and how those need to be updated on a regular basis. Let me take that off. Cool. So let's have a look at then some of the sort of developer, what I would call security mindset concepts. So in general, most of the issues that I come across and that we see as a company are not so much if there was a problem or a fault due to the third-party application. In my case, for instance, the log4j, it would have been, but a lot of the time it can be misconfigurations. It can be things where, for instance, it just wasn't 100% configured. I read a very nice article recently about penetration testing against environments that typically run Active Directory. And it basically said, things like Active Directory will typically leave this port and this port open, in which case that becomes not necessarily a known exploit, but it becomes a known method for people to test whether there is anything where somebody can maybe gain further access to, because it hasn't been locked down or it hasn't been closed or customized for what that company is wanting to do. So a lot of the time, misconfigurations can be as simple as you install a network device or a router and you leave the default password as the default password. And somebody happens to know what that sort of brand or makes default password is, and therefore they can gain access to your network. Or a lot of those sort of things where people maybe don't do due diligence or don't have a proper security policy. They don't kind of have what we would term like a security baseline, in which case then they don't always know what they're trying to work towards. And more importantly, they don't understand where the possible attacks can come from. So that is really where a lot of the value in terms of engaging with a security expert or those sort of companies who see this a lot comes from. It's a sort of thing that for yourself as a developer or even as a sysadmin, the amount of environments you're going to set up and deploy over a year or 3 years is very low compared to somebody who's doing that as a consultant or as a profession, in which case they will see and be on top of a lot of these sort of vulnerabilities and the best practices for it. So from my side, first and foremost, something that I've seen hugely improve over the last 5, 8, 10 years is just the amount of available information to developers. So if you are starting something, Google things like reference architectures, best practices, security things. Don't just decide, hey, I'm going to create something in whatever language, PHP, Python, Node, React, and then I'm going to create it this way, and that's how I'm going to run with it. Spend an extra half an hour or hour, read up a bit about, is this the better practice or framework? Or if I'm using that, are there any kind of standardized best practices that have been put forward or discussed by people? And why are there concerns around X or Y or Z or certain methods? Maybe it's to do with it introduces certain vulnerabilities or it makes certain things a bit more prone to X. And maybe that's something that will refer to certain terms or concepts that you need to read up further about. Maybe it refers to CORS or cross-site scripting or SQL injection, in which case you don't need to become an expert on those concepts, but you should, if you're a developer or an admin, at least understand enough to know what does that attack mean, and how does that sort of look, and what am I trying to compare? So let's give a simple example. Again, if you're looking at, say, Python versus PHP and whether or not to put a WAF in front or a firewall in front, what is the firewall actually preventing? What is the value add of it? And is that something that I want to spend time on now? Do I want to look at spending time on that later? Or is it something where I'm prepared to accept the risk and not implement it? But at least then you're making a more understood decision around a lot of those sort of things. So that's what I would refer to in terms of kind of defining a security baseline, understanding what are you trying to achieve and why are you trying to achieve it. So then from the mindset concepts, you always want to be looking at how people are accessing your application. Do you need identity access management? Do you need it for each user? Do you want it for this? And this can be for the AWS environment. This can be for your application. it comes back to kind of how are people working with it? Where are you doing your authentication or your authorization? And do you need something like an identity provider? Do you want to use something like an AWS service like Cognito? Do you rather want to use federation against like Google or some sort of single sign-on? How are you handling things? Because again, this is easy enough to come back to later as a developer, but often what happens is people have a great idea, they want to run with something, they build it, it becomes a POC, then suddenly there's a lot of interest and a few new features are there and people go to market, and security is often not circled back to. So it always becomes one of those interesting trade-offs with, hey, this thing's going to take me 100 hours to develop and so that I can show, 10 people and see if there's enough interest in it. I could spend 10 hours now and actually, create the proper structure and a nice set of security, maybe a nice user group table, or create an auth layer and maybe use like, JWTs or some sort of authentication tokens, so that, for instance, silly scenario, like when you do a forgot password or a reset password on a site, you sometimes will get emailed a link, and there will often be a thing saying this link is only valid for 1 hour. That's a security concept to try and restrict people clicking on a link from somebody's email from 3 months ago, because you now have access to someone's email. Maybe something happened, or maybe you compromised their mailbox. Your website or your software shouldn't suffer because of something, that has happened 2 months ago, in which case build security into your process, understand how that can look and what best practice is, and try and always put sort of time frames in to kind of make sure that there's limited risk and scope. So again, those sort of things, by putting time spans or lifespans, can often be done through tokens. Often sites will interact with each other using tokens. So for instance, if we're creating a site that maybe is calling, I don't know, Salesforce to pull information from their CRM or their CMS, you might find that you are first wanting to do a call and you pass through your credentials, and then all of your subsequent calls, you're not needing to repass through who you are. You're just passing through an already authenticated token that is valid for that session. And then if there's any sort of issues, it doesn't matter. That token's unique. There is complete traceability. And then at least it becomes a lot more structured in terms of what you're logging and what you're tracking and stuff. And again, those are the sort of things that you normally want to define both as a system administrator, as a developer, and you really want to make sure that what you're allowing people to do or what you're exposing has been kind of nicely thought through, and that you're kind of happy with a minimalist approach in terms of how much information's been available, how long is it available for, and a lot of those things. So yeah, and then similarly, how do you restrict that and make that even tighter? How do you know that Terence who's logging in is really Terence? Can you look at implementing MFA or 2FA? Maybe, some sort of authenticator on the person's phone, or some sort of method of ensuring that there's confirmation and that user is who that user is. Maybe you want to build in a nice to have where the person can say, yes, this is me, remember my device, and then maybe you record their MAC address or IP address or something like that, probably MAC address of the PC, so that if that same user logs in tomorrow, you don't have to ask them for the MFA again. Or, again, you might find that for a banking app, that's definitely not where you want to go, and you want the person to use the MFA every time. If it's maybe for another sort of a site where maybe the data isn't quite of such a sensitive nature, maybe you do want to look at those sort of things. Again, there's generally a wealth of knowledge around best practices or suggestions and things, and there will often be certain blocks of code or ways to do it, or things like that. So what I generally see is, a lot of the time, a lot of the building blocks that you use have been done before. You don't generally need to reinvent the wheel. It's often your final product might be different, but a lot of what you're doing won't necessarily need to be different or shouldn't be different, particularly with security first. Yeah. Then A couple of other key concepts around security and mindsets for people is very much you want to reduce the amount of hands in a production environment. So a lot of where your typical sort of methodology of deployments and releasing code into production would be that somebody would SSH on or RDP onto the box, or they would FTP to it, and there would be port 21 open, or secure port 22, and then people would basically update their code or send it up. Then what basically happened is they started becoming a lot more of a DevOps practice of CICD, or trying to push for rather allowing code to be updated in production environments where you didn't need to have lots of people things. And therefore, one of the main benefits is just to reduce the amount of hands or people needing access to production environments. So there's lots of ways of doing it, but effectively, again, if you're the sysadmin, ideally you want to have it so that only you have access to the environment. So you know everything that's there, and there's nobody else messing around with your environment, and you take ownership of it. Obviously, you want processes in place so that if you're on leave or somebody else can take over. But what you want to try and restrict is too many people doing things that you don't have control of, or having too onerous change control processes or things like that where people can't action or get to certain things. That can also be done by what they call like IAC, or infrastructure as code, and that's the method of normally deploying your environments and your EC2s and your databases using some sort of scripting language. Typically CloudFormation or Terraform are probably the two most common. And that again is a security mindset to prevent people needing to do as much or with hands-on in the production environment. Another key thing that we see quite a lot of is access keys and how they get used and what they get used for. And these can be very dangerous. So at a top level, for those that aren't too familiar with access keys, let me explain how and where they get used. So for instance, as I explained, if you want to not have people FTP, or you want to create a code pipeline, you might very well create an access key. If you're wanting your user to be able to upload files to your S3 bucket, you will typically do that via an access key, which therefore grants permission to that resource based on the key that is provided. The problem can be is if that key ever gets compromised, or if that key never gets changed. What can happen is 2-3 years later, the same key is still being used for the same process. Maybe your team is now 3 or 4 or 5 people. Maybe one of them's left the company. Maybe there was a fallout. He can still use that key to do what he was, unless you're rotating it or restricting access. Or you get a lot of scenarios where the access key is as dangerous as the user's credentials, but people or developers don't always pay as much attention to them as they would with maybe having an offboarding process or removing people who have left the organization. So access keys can sometimes be a bit of a hidden challenge, which sometimes gets ignored. But in concept, you really want to understand where are things stored, how are the developers using it, what are access keys used for, and stuff like that. Then, as I've probably mentioned previously, I would always lean towards encrypting as much as possible, encrypting your data at rest. It's very easy under AWS. It's generally a 1 or 2 clicks and stuff. For S3, for your EBS volumes, for however you're storing your data, unless there's a reason not to encrypt it, I would generally always lean towards advising encrypting it where possible. And also just understand what data you're storing where, and whether it's sensitive data or not, and just make sure that it is encrypted. Whether you're storing, maybe you've got some sort of a KYC or a know your client process in your application. If the person's uploading a utility bill or some sort of a statement to prove that this is their address or this is where they live, where are you storing that? Is it encrypted? How is it being accessed? Is it being accessed via an access key? Those are the sort of things, again, you just want to be looking at, well, shucks, how could I be doing it? What maybe are some best practice or secure ways of doing it. And maybe let's kind of see, maybe I need to store it in an S3 bucket and only be able to access it through a key. And maybe I will then have it so that my application assumes that role and gets access to it. And therefore I basically prevent everybody other than my EC2 being able to access it. Or, what other methods are there where maybe you can try and lock it down or restrict it? Then understanding attack threats. This is a very useful thing to try and kind of push your understanding of what is happening out there, or why are there certain best practices that are constantly changing, what is happening, and what do a lot of the things mean, or at least how can they happen. So like a man-in-the-middle attack, you might find, for instance, let's take it, say you're running a WordPress site or something like that. Maybe there's a plugin vulnerability, and maybe somebody can go and drop a little file on the thing that basically just does maybe packet sniffing of one of the ports leaving the server and going to the database. But that basically means unless that traffic's encrypted, they can now read all of your queries to the database in plain text. So if you're taking card payments, can they go and be able to harvest all that data, or the card transactions or card details in plain text going out? What does that attack threat actually look like? How can you mitigate that? Is that something that can be looked at via X or Y? Or, understand maybe where these sort of things are and how they can be looked at. And then the obvious one, which sometimes people kind of leave till bit too late sometimes, is back up your data and test it. Don't just make assumptions, always plan for failure. And again, maybe it's worth just highlighting, if you make a snapshot of your database and you leave it at AWS backups, typically there is a rotation period, maybe 7 days, maybe 14 days. Do you have a lifecycle rule that moves that to maybe an S3? If so, what is that? And then on S3, do you have a lifecycle rule, or are you putting it in a bucket where you have like a MFA delete policy that you can only delete it with a MFA? Because again, let's take a scenario where your account gets compromised. Maybe somebody gains access to your credentials. Maybe you had a weak password, maybe any number of things. The person logs into your account, sees your data, copies it down, deletes your database, and deletes your backup, and deletes what's on S3 because you haven't set it up for that they need an MFA, and you maybe don't have versioning enabled, in which case, do you have a copy of that data outside of your AWS environment? Do you have a copy in either Glacier or some place where it can't be deleted by somebody casually? In which case, you kind of are doing a similar thing to if you were running it on-prem, where maybe you've got an external hard drive or some sort of a backup device, but you're leaving it in the server room. And if you had a fire, you would lose your server, your data, and your backups because they're all kind of stored in the same location. So again, you want to just be kind of planning for failure. You want to be kind of working on the premise that something can happen. What is the easy kind of offset, and how much work is it to do? What is the potential cost for either storage or for automating it? And then, table it on your roadmap and see, well, is this worth looking at? If so, who's going to do it, and if so, when? And then at least you've kind of got a roadmap in there. So those are some of the key sort of concepts that I wanted to kind of run through. Then more for the developer, I had a couple of things which I also wanted to, hello. Sorry, practical developer thoughts. So some nice thoughts for developers in terms of if you're thinking things through and you're structuring your development team, maybe it's you and a mate, and you're kind of working out how to do it. Again, you can look at a lot of secure coding methodologies or standards, or how to maybe do a naming convention to make life easier, so that if you suddenly get 2 or 3 people working on different modules, you don't find later on in your application that it's a bit of a mess, or it becomes a lot more difficult to maintain. Developers typically call that technical debt, where they often might need to fix things later to make it work and make it more efficient and easier to maintain. And it can happen a lot when you take over other people's code, particularly if it's been worked on by multiple people over time. It's very hard to always take over someone else's code and code it in a similar way or structure to how they were doing it. So inevitably there will be differences in terms of how different people's coding styles or methods come through. So what this would be looking for is peer reviews. So one of the easiest ways and also one of the best things for secure coding is when you're doing your commits to your repo, is somebody else does the pull and maybe has a look at understanding what that code is doing, or at least kind of having a look at it. And there's a lot of things around that. CICD is, as I mentioned, we can cover that maybe in the subsequent ones with the deeper levels. But in concept, for those that aren't too familiar with it, a CICD is like a concept around continuous integration, continuous deployment, where you are regularly creating more of a pipeline so that your developers are not needing to log into the environment or FTP or SSH in to update the code, and you rather do it through an automated means. It's got multiple benefits. It's got no real downsides other than the time taken to set it up and maintain it. But if it's working well, it saves a lot of time to the developers, but more importantly, it improves security and makes the environment a lot easier to manage. But again, it might not be a low-hanging fruit when a project starts. So it might be something that only gets added 6 months later or whatever, when it starts becoming a bit more of a mission. Or you might find you do it from the beginning with the view that things. So it really depends a lot where the developer's skills are or where that thing is, and also how many developers there will be on the project. If it's largely just you, then probably isn't got quite as much benefit as if there was 2 or 3. As I mentioned, there's a lot of tools and ways of doing things, understanding what they detect. So you've got obvious things which you'll probably hear about, things like firewalls, things like antivirus. AWS has a bunch of security services, which again is very much worthwhile understanding where they fit in, things like CloudTrail, GuardDuty, Security Hub, what config, those sort of things. What exactly do they do? How do they work? They've got third-party tools. So you've got a lot of things like monitoring tools like maybe Datadog or Prometheus, Grafana. You've got a lot of security things. You might hear things like SNCC or SonarQube for maybe scanning code and vulnerabilities and looking for libraries. So at some point as well, if you get a sense that some of the stuff is not everything it could be, then there's probably tools or methods to do it. Again, it's unlikely that your challenge hasn't been encountered previously or that there aren't tools or ways to do it. And there might be things. So a lot of the time it will come with a cost. There might be a free tier. But again, it's useful to just be aware of what other companies are doing and why, and what is the potential risk for it. And some of those can be mitigated by the next point, which is like reducing the attack surface, which is typically looking at like maybe running a hardened operating system or antivirus. Similarly, if you're running things on like EC2s or ECSs, you want to update or patch is what they term it. So patching simply means that you're running an updated version of your operating system. So for those that run Windows on your laptops or your PCs, you will inevitably have seen Windows always has a thing called Windows Updates that you can click on, and it whirs and tells you if there are any updates you want to apply. Do you want to update it now? Do you want to update it later? That in concept is as simple as what patching is. The risk can be is that people deploy a server or a web server and they don't ever effectively click on that button or see what patches are available. And Microsoft, the Linux community, whichever operating system you run, might be bringing out regular patches, maybe, several a week or whatever. But if nobody's patched that server in 6 months, a year, 2 years, at some point there's going to be quite a lot of vulnerabilities that are on there. Will it be an issue? Who knows? But the question is it worth taking the risk and for how long? So again, just be aware that the concept of patching is something that you do want to look at sooner rather than later. But yeah, that's the concept. Detection, monitoring, and alerting again is speaking for the developer in terms of what am I writing? What am I wanting to monitor? How am I wanting to know if my workload is running efficiently? How do I know if it's if I created instances that are too large, if my database is too big? Is this thing optimal? I was chatting to a client a few days ago. They were having a Lambda function that was reading a file and processing it. It was timing out. Lambda's time out after 15 minutes. We thought it through and we said, well, why don't we try and do it in a different method? We then basically, brought the table file through into a temp table. We did a bit of queries in terms of joining it and doing whatever instead of it rather running one SQL statement per iteration, and it dropped from 15 minutes to 3 seconds. So by understanding what is running or being able to kind of monitor it, it gives you a lot more insight in terms of where are your potential bottlenecks and what are you as a developer creating because you just haven't tested it, or you haven't tested it with large enough data, or versus maybe there's a slightly more efficient way of coding it. Maybe your queuing mechanism works great for 10 records when you're testing, but if you're actually testing with 100 users with 100 records in, your queue of 10,000 isn't working and falls over. You don't know that until you've tested it a bit bigger, but always try and think that extra step as to how will your application be used and try and test it in that manner, so that you can do it. And a lot of the time that's difficult. There are tools where you can automate or script or write it to kind of simulate traffic or kind of automate the processes as much as possible. Because, a lot of the time, the best developers are the laziest developers because you don't want to keep redoing the same thing that becomes boring. You want to be doing more things with your application, and you want to be working kind of, I wouldn't say smarter, not, harder, but you want to be aware of where the challenges are in the application and where there might be better ways of doing it or tooling and stuff like that. And then lastly, just a thing that I don't always know if people fully kind of understand or go down, but a lot of the things around the web applications and that sort of thing is around like SQL injection and various types of data moving between. A lot of the time people create APIs now, and that's very kind of common. But one of the things that people don't always do 100% is like data parsing, data cleaning, sanitizing your variables. In other words, for those non-developers, that's as simple as saying, if we create a function which expects a username and a password for somebody to log in, is the username I'm getting actually kind of in a valid format? Is the username Gareth123, or is it my email address, or things? Should I honestly be expecting something that says, Gareth semicolon double quotes and 1 equals 1, or some sort of SQL injection? Or how are you writing something so that it can eliminate dodgy characters or things where people are obviously trying things that they shouldn't be doing? And can you be putting that into your kind of data cleaning or parsing of that data to make sure that your functions are only accepting sanitized or cleaned data, and just kind of trying to, again, build that into your application from the beginning and thinking it through. Then lastly, I wanted to just kind of cover one of the main tools that I've seen over the last decade or longer. It's called the OWASP things, which is a standard awareness document for developers. I think it stands for Open Web something, something, something. And what's nice about it is it's constantly updated. It tells you what are the main top 10 vulnerabilities or risks that they are seeing in the wild, and what is the normal sort of methods to do it. It's completely language agnostic. It's more of a a framework standard, and then it's up to a lot of the individual communities who maintain the languages or write things to make sure that there's best practices on how to address it. And as you can tell, these things kind of move. So like broken access control has moved from number 5 to number 1 from 2017 to 21. You'll see that, for instance, SQL injection was number 1. It's now number 3. Now you'll see cryptographic failures has become more common in terms of things. And cryptographic failures would again be speaking to possibly access keys or possibly things which aren't working as intended. But you'll see that there's a lot of the other sort of normal sort of things like insecure design, security misconfiguration, vulnerable and outdated components. So that again speaks to patching. You know, you write a nice little React application. Are you still running an older version of React because you don't think it's important to upgrade, or you went to go and try and some of the stuff broke and was, you know, looked like it would take more than a few hours to update and you didn't have time, you know, all those sort of things. But at some point, you've got to be aware that there are lots of tools or scripts to purposely exploit vulnerable or outdated components. Same with all of these things. You can pretty much probably Google and find toolkits or things to basically simulate or attack things to see if you can exploit a lot of these things as well. They're not that difficult to find if you want to go that route. The more common white hat sort of method is to actually have people who specialize in penetration testing or certain ways to do more advanced testing tools and QA tools that will identify a lot of these things. And again, the other thing which interestingly has kind of snuck in here is the cross-site scripting and the server-side request forgery. And those are two things which also from a web perspective are worth understanding. And that can be as simple as saying, let's keep it simple. Let's say on your website, you want to use a special font that looks really cool. So your developer includes the CSS or a link to that library, and maybe it's a whatever font published by somebody, and you simply include that. So instead of you downloading that file and including it in your code or your app on your server, you rather point to it and you include their file as a library and stuff. Now, sounds all fine, and developers have done that for years and they still do. The obvious problem is for me to inject code or do stuff to your website or affect your users, all I actually need to do is be able to take over that file or adjust that file that is being passed to you that you are accepting and trusting from the third party. So your security could be rock solid, but if I can affect what that site is doing, therefore I can affect the plugins and all that is being used by all of those sites. And that's where you'll find that certain of the attacks for, I don't know, like a WordPress plugin, if a WordPress plugin isn't secure and kept up to date or gets compromised, you can then affect loads of sites that are using that plugin. And often they won't even be aware of it. And if you keep it relatively innocuous and people don't figure it out, you might be able to find that you can then cause a further exploit. Maybe you then allow people to drop a file on. So if I can tell that, you know, people are using my file, I can now have a backdoor and I can start doing more, etc., etc. So effectively what cross-site scripting and and the server-side request forgeries are doing or checks for is they by default don't want to allow your site making calls to any other file or library that's not on the same URL. So if your URL is overdrive.co.za and I've got a link to pull a file from another site, it will deny it, or it will throw an error, and I need to either explicitly allow it or that function won't work. And that's kind of where, you know, you start seeing more standards or more ways of trying to force developers to consciously accept that risk, or rather find ways or workarounds so that they mitigate the risk. But yeah, so the OWASP is one of a multiple other frameworks or standards. There are several others, but really and truly it highlights a lot of things. I think calling it an awareness document or framework or standard is a very nice way of putting it, because it really then just does force the conversation and make sure that, you know, if developers are seeing it, they should know what it basically means, and maybe read up then on possible ways of circumventing it or mitigating it. Otherwise, that's it from my side, guys. Let's open to some questions then. As I said, I didn't want to delve too deeply down because I fear some of those things might have been a bit, yeah, unrelated to non-developers. So I tried to keep it as overview as possible. But yeah, I did have one question put through from Janet, which is or Selena, which was, what is the future of cloud computing? Which is a very, very open-ended question. So maybe I'll come back to that one at the end and start with your other questions first. Cool. I see a couple of hands. Maybe let's go. I don't know who was first. Terence, or Eric? Do you want to maybe moderate, or should I just go?
Yeah, you can go on, but let's start from Alfred.
Hi.
Alfred. Okay, good.
Hi, Gareth. I wanted to ask, for someone moving towards DevSecOps, do you have to be a good coder to excel in the field?
No, absolutely not. You don't have to be a good coder. You need to be open-minded and willing to take constructive criticism and read up and take ownership for what you're doing, Alfred. That for me is the most things. So because that will naturally mean that you become a better coder. You don't need to be able to, you know, write rocket science code. What you want is solid code that is completely trustworthy, that you can then help the rest of the team if that's the function that you're fulfilling in the DevSecOps. Because a lot of the time, your code in DevSecOps is seldom going to be more than, you know, 50 lines of code here and there for certain scripts and things like that. So then it would become your role to understand standards and to be kind of helping create like a policy or a thing that other people are following, so that you kind of lead from the front.
All right, well understood. Thank you.
Okay, thank you, Alfred. And we have Lahab.
Yes. Hi, Gareth. Hi, everyone. My name is Rehab, and I'm an aspiring solutions architect. So I had a question about in terms of security. So in regard to the software development developer lifecycle, where would you? I have actually two questions. So let me ask the first, and then I go to the second one. Where would you say the greatest security threat would be? And what would be ways to be able to kind of mitigate those security threats? And for my second question, I had a question about the CICD pipeline. So I read up somewhere about the security threats when you into a CICD pipeline, and I read that it says something about you are attempts to detect and remediate potential risks to application security threat throughout the phases by shifting security to the left. So that's the phrase I really didn't understand. So maybe if you could expound on that, I would really, really appreciate it. Thank you.
Thanks, Rehab. So the answer your first question is a bit of a open-ended question. That's a bit like trying to teach somebody to drive a car, and they kind of go, what should I focus on? Should I focus on the brake or the clutch or the steering wheel, or should I be looking at my side mirrors? And you kind of are sitting in the passenger seat cringing, saying, well, preferably all of it, because, you know, if you don't do any of it well, we're going to have an accident. So the security in the SDLC, or the software lifecycle, there's a lot of things that can be done at a light level, and people have been doing that for decades. It's not an issue. It's, I think, trying to create more of an awareness of, if things can be done better and where they should be done better, and then where does your team feel that there needs to be that addressed and stuff. So in general, things can always be looked at, and I think it's a continual improvement. I think it's something where you need to decide, and maybe ultimately that comes back to the person leading the project, is what are they trying to achieve and what are they prepared to accept, or what standards do they want from it. So the simple thing from my side is the application needs to be fit for purpose. So if you need a secure login, then that needs to be done. But you don't want it so that somebody else can come along and easily break it or bypass it because of X, Y, Z, or find that people have done certain things that are a bit peculiar. Those are the sort of things where there's becoming a lot of best practices that makes it easier for people to improve, but it's not as simple as saying there's one key thing. It's a continual or a holistic set of things that need to be done. I know that sounds a bit vague, but it's really not as simple as do once and then move on sort of thing. It really does come down to continually evaluating as you go.
What about the designing phase? Is that where you would say a lot of security is applied during when being created, right?
100%. So you're 100% correct. So your biggest thinking should be upfront. For the application itself, it should be in the design in terms of how the system will flow, how the interaction will work, and that should include how certain security handshakes should work, or what sort of things or whatever. Maybe at that point, the actual protocol or the actual method used isn't important, but in concept, you want to make sure that the application is going to be secure and where data is stored is going to be secure in terms of the user flow. From a company level, you want to also be looking at, is there some sort of a policy or a coding standards or something where the team then goes about implementing that in a secure way? And then the DevSecOps or the DevOps side is more a case of making sure that the infrastructure they're deploying into has security considered and discussed in terms of that, rather than leaving it for the developer. I can tell you for free, my experience is developers seldom put the security of the environment first over and above the building cool stuff, because that's where their focus is. So some developers can do both, but in general, that most developers are leaning towards understanding their application stack, understanding what they're trying to build, and they just want to deploy it and see it work somewhere. They're not really going into the nuts and bolts of, is it actually working securely or can it be improved there? That they generally would need somebody else to be kind of taking ownership of the environment and leading with questions and stuff there.
That's clear.
And then with regards to your other question about the CICD, what exactly was the phrase that you used, or moving it to the left?
Yeah, shifting security to the left. I read that phrase and I didn't understand. So I was like, maybe if you could expound more so I could be able to, because it sounds like
it's not a phrase that jumps out to me. I think it might be talking about at what stage it's looked at, or shifting it so that it's a higher priority or considered earlier, but I would need to see the actual article there to just fully understand it. Off the top of my head, it's not a term that jumps out at me.
Oh, okay. Yeah. So, but what are some of the best practices that can be applied in regards to when you're
CICD?
Exactly.
Look, this is a level 100 course, Rehab, so I'm happy to dive into that. But in concept, there's several ways to build CICDs. You can obviously do immutable deployments or mutable. You can then things, but generally the ones that we normally lean to ourselves internally is we normally use Bitbucket code deploy, and then so in concept, how it normally works is the repo will trigger an action that then will do scans on the code, make sure that they pass a set of tests, that then will build the artifact or the resulting files that get pushed up to S3, and then you run an agent on your EC2 or your Lambdas or wherever that then basically take the code and pull it down and then update it in place. So you can get different pipelines, you can get different tools, you can get slightly different ways. There's a lot of features in terms of CICD that you kind of do need to just consider and work through, like what happens if you've got multiple features in your repo, or do you kind of have multiple branches for that? How do you then merge them in? How do you do this? How do you do that? So it can get a bit more complicated, and some of the tools make life a bit easier, like the ones from GitHub, Bitbucket, Code9, Azure DevOps. Those ones can do things, one or two things, a bit easier than others. So it depends what you're looking for. It also depends if you're building a container and deploying like a container, or if you're actually deploying the code straight. So there's definitely things there, but again, there's definitely a lot more repository actions that are available now than there were several years ago. And if it is something that interests you, I strongly suggest looking up and reading about the repo actions and things like SNYK, SNYK, SonarQube or SonarScan. Those are kind of the two most common tools that we normally see people using that can do a lot of features and vulnerability checks and things. And then there's also a lot of third-party tools that can do a lot of code scanning and stuff. So like a simple example would be when you do a build, you don't want to allow the code going through if you find there is a config file with database credentials in, because that shouldn't be in the repo. You also don't want to allow access keys in the repo. So those shouldn't be in there. So there should be certain checks to make sure that if a developer goes and pops that in, don't allow the build, refuse it, don't allow it in your production environment. Or certain other things that maybe you want to put in or restrict, and things like that.
Yeah, thank you so much, Gareth. You really answered my question and then some, and even gave me assignment and homework. I'm really going to. Yeah, I've been really curious about this, so I'm going to read up more on this. Thank you so much.
Oh, absolute pleasure. Cool.
Yeah.
Any other questions, guys? Otherwise, it's, yeah, that was definitely not a 100 question for those that maybe didn't follow all of that.
I saw a hand of Terence. Terence, did you have a question maybe to ask?
I was only adding more insight into what Rehab had asked with her question number one. You see, look here. I don't know how to put it, but let me say the only constant in this game is change. And the game has been changing again and again and again. If you're talking to old people like me and Gareth, we come from a world where things were being thought about differently. Let me say, like, as an infrastructure guy, do you know what we thought? We'll build the network, and then after that, when we are through, we've delivered, they will tell us, okay, what about security? We say, okay, we'll give you a next generation firewall, put it on top of your network, you're safe.
I thought security was locking the office door when you left at night.
Yeah, it was just, security was more of, like he's saying, you just closed your front door. But you see, for you, you've come into a different paradigm where it is like security has to be built from the ground upwards. Or to put it in what you guys interact with in cloud, you call it security in depth. You peel one layer of the onion, there's another security layer. You peel another layer, and what are we saying? We are saying you will meet a knuckle. Before you hit the security group on the instance, you are likely to meet many other things, from load balancers, which have some security input into it, all the way to, WAF, Shield, etc. So your world is very different, and it's because of the ramifications that security has come with. Even the best built software will always present the so-called zero-day threat. We went to production with it, and yet some genius somewhere, evil genius somewhere out there in the world, figured out that there's a vulnerability in the software. So what to do? That's what I'm saying. For you, your world is not like the world when we were being trained. Your world is totally different. Security has to be built from the ground upwards, and it's not an extra module. It's not something we slap on. It's not like Gareth said, it's the front door key that, okay, we will use it and then we'll go away and our home is safe. No, the threats have become so many, and therefore that paradigm shift is necessary. When I first began all this, IAM was never there. But can you see what security construct IAM alone and how it allows you to access and get into your apps is? So can you see, for some of us with white hair, we've really struggled to get to terms. We've really struggled to come to terms with what is going on. But for you, it's so natural, Rehab, as in, you found it this way and it's just going on. But now we have to build security from the ground upwards. It's not just another extra module. It is a critical thing, and it can really embarrass you, also cause a lot of losses. And I mean, what security can do is like you can't imagine. It can cause so much chaos. Over to you, Gareth.
No, 100%, Terence. It's so much. It's chalk and cheese compared to things, and the ability on what to do and how easy it is to deploy. So like in the old school, if you wanted to suddenly, double the RAM in your server, you would order it, wait several days, then have to wait for the engineer to open up. Now you can spin it down, start it up. It's 5-10 minutes later. It's, cloud has completely changed a lot of the thinking and ability to test things at scale or be able to run with it. So maybe going back to the other question about the future of cloud computing, look, we don't see any clients go from cloud back to on-prem or anything like that. Yes, there might be certain concerns for certain workloads, or maybe people retire certain things rather than kind of change it. But cloud gives you just so much more flexibility, the ability to suddenly say, I want to run this on 32 gig of RAM, or I want to increase that as opposed to changing it, or hey, I want to now encrypt my hard drives, redeploy my application and pop a firewall in front. It probably take 3-4 hours. I mean, old school, ask Terence how long that would have done to go into the server room on a server. You're lucky. Set up a load balancer, suddenly spin up 2 servers and balance the traffic on a round robin between 2 servers. Heck, that would have taken a Linux engineer probably, a day or 2. So a lot of the things make life a lot easier. And I think with a lot more of the ML stuff going into the cloud and being able to run models, chat AI, GBT and AI models becoming a lot more prevalent and powerful. There's a lot of talk about, that sort of stuff becoming available to run on your phones in the future. You can train your own models, do your own things. It's a constantly moving space that everybody is excited about how it can benefit them, but security is always that hidden elephant in the room that as developers and as admin, it's our responsibility to never lose sight of, and therefore, always kind of make sure that we're keeping other people honest in terms of how they're going about things or what they're doing, so that, there's not mishaps in the organization. Otherwise, that's it from my side, guys. Are there any other questions?
Yeah, you can still see Dennis. Dennis, maybe if you can unmute yourself and talk, otherwise I will read what you have written in the chat. Dennis, are you there? Maybe not. Then he's asking, can you elaborate what DevOps entails? He's saying, I'm a student, I'm a CSA student. My end goal is to be a DevOps. Maybe if you can talk a bit more about DevOps and
Yeah, so DevOps is an interesting term that a lot of people use very loosely. A lot of people associate DevOps with just code pipelines or CICD. And in essence, at its core, DevOps is about automating the infrastructure so that it can run more efficiently or more optimally and be more things. So for instance, generally with DevOps, if you're wanting, you can be quite happy just doing code pipelines for a company that maybe has loads of workloads that need support or new things enhanced or sources from it, in which case it's now working in an automated way. It's easier to deploy. DevOps could also be building the environment or scripting that using Terraform or CloudWatch. You can create your environment with Terraform and control it through Terraform state so that your only changes are allowed through your Terraform, and that can include the monitoring and the maintenance of that as well. So you can get different functions. It's a bit like in developer, you could be a front-end developer, a back-end developer, or just a database specialist, but you're technically still a developer. DevOps can have different hats that can do everything or don't overlap. But in essence, a good DevOps person should have some sort of programming knowledge, be able to write scripts or be able to read scripts and adapt it from other people, and be able to apply those scripts to their environment and understand fully what they're doing, and be able to dive in and research tools or other ways so that they're not wasting their time writing scripts that maybe for 1 cent an hour, we can rather get the business to buy a tool that can do something that's going to take you 30 hours to create. It's not necessarily the best use of your time. Those are sort of the things where DevOps can be a bit broad or mean different things to different people. But in concept, you're not really developing an application. You're using your scripting skills, your development skills to maintain the environment or help the developers with the tasks that are more on the infrastructure layer. Does that kind of answer, Dennis?
Yeah, little.
Yes,
Dennis
thank you.
is. Oh, good.
Cool.
Then there is another question here. Are there internship opportunities in Africa for AWS? What can you say about that?
Sorry, Eric? Are there opportunities? Oh, internship.
Yeah.
Yeah, there's lots. As far as I know, I could be wrong, but I'm pretty sure AWS was running a internship program in Kenya, as far as I know. But I'm sure Terence would be able to reach out to the AWS team and find out more about that. But my understanding is there's definitely a lot of push towards skills and the upskilling, because we can't support all the organizations as more people are moving to cloud without more people coming through with the skills and putting their hands up and wanting to get involved. So it's a continuous growth process. So yeah, there's definitely are. What exactly they are, I can't speak to them.
Well. Thank you. Terence, are you there?
Cool.
Yes, I am here. At CSA, I really want to share with you this piece of advice. The minute you hit level 2, I really want you to get rid of internship and think more of entry-level job placement. And I want you to take this risk. Go out, even when you certify tomorrow, the day after tomorrow, I want you to go out in the market and say, I am a solution architect. And today, when you're in class, I want you to go to your LinkedIn and say, you are a solution architect in training. Say CSA began in April and training ongoing. You say it began on this date and ongoing. That is the audacity that will enable you to, when they open the door, you can put your leg in. For the CSA person, I really want you to get rid of the internship, trainee type of, let them place you on probation, but also have that audacity, not only to present and position yourself that way, but on the other end, guys, this thing is very difficult for all of us. Even I go to places and I find a lot of bewildering technologies. But you see, the difference between you and I, the gray matter, your gray matter is really growing and you've got the adventure. You know, how can we run MLOps workloads? Terence is not going to be that. Terence is very conservative. He's just saying, I know. So what I'm saying is, you've got an opportunity to do certain things that we, at this point in time, we're already set in our path. For you, you can try to add a little bit more things on your GitHub profile that are slightly different from what I would ever have. You have got the chance to try out the new stuff, the futuristic stuff. I mean, right now, everywhere I go, I hear people talking about generative AI. Do you know, even for Terence to go and type something inside ChatGPT, he goes there thinking that If I don't type well, I might blow up, I might break something. But for you guys, you're getting embedded in. So yeah, put those things in your profile. I tried out this workload here, I tried out. You will be shocked. You will be shocked. And I'll also share a story in that line. Once upon a time when I was a startup founder, we really liked playing with the USSD applications. They were pretty new to us. We never knew. So you can imagine how excited, because there's a very famous USSD application that uses SMS notification, wild famous. It's called M-Pesa. For us, we use it here in Kenya, and it was a shock when it first came out. And when I went to school, when I saw it, I mean, when a teacher told us you can write USSD code like this, we looked at him and said, but that's so simple. That is perhaps. Then we went out in our startup. We did do a lot of USSD things, and when we were approached by a Nigerian presidential candidate to help him count elections at his various, Nigeria is very big. So he said, for my agents, I want you to build an app that will enable us to collect the results. I mean, the electoral body will announce, and my agent will also send. So I will compare what my agent is saying and what, when I'm in Abuja, I'll compare what my agent is saying and what is officially being said.
Wow.
We did it. But before we could do it, we were afraid. We are just university students. What would we know about USSD? We know XXX company that has already done a 500 million Kenya shilling app, which is USSD for the Nigerian Ministry of Agriculture. They should be better off to do that. But that particular presidential candidate said, no, I don't want them. I want you. And what was the basis? Because we just tried. We had tried a number of experiments, and we were able to show him 50 different prototypes. So what I'm trying to say is, what you are doing with your trainers every day, don't take it for granted. I do meet a number of you documenting stuff, putting it out there on LinkedIn, say, oh, Terence gave me this assignment last week, I did it, this is how I went about it. I mean, you put the code in your GitHub. That is what makes the difference. You don't know who else is looking. I mean, Gareth is there in the background looking, and you might like, hey, I want that person. Give me Dennis. I saw his work. So do not underestimate what you guys are doing on a daily basis and the small experiments you are doing left, right, and center, because those build you and build your profile even far more than the knowledge base and the skill set. I mean, the ability to be audacious, the ability to take those risks, the ability to try out, the things that Terence fears trying out will differentiate you. And then do not fear. That's also an element of imposter syndrome. Do not fear to go and present yourself out there as, I'm a certified solution architect in training. Don't go say intern, I don't know, those other things, trainee. No, that one, leave it. When you were doing CCP, the foundational crowd practitioner, there's when you were using those names. But for now, for the CSA candidates, you are to look at yourself, change the paradigm shift on how you view yourself. Get rid of, fight the imposter syndrome and just present yourself and what you have. Gareth won't be angry if you say, I don't know that, but give me 2 days, I'll research, I'll get an answer back. Or in my research, I've not dug to that level, I've not decomposed my research to that level, but what I know is this. Hey, give me 6 hours, I'll be back with an answer to what you're asking. That is far more different than saying, I'm just an intern and that type of thing. I don't know if I've helped. Dennis, I don't know if I've helped in any way.
It's the same as my answer to Rehab about the shifting to the left. I'm like, it sounds vaguely familiar, but, you can't know everything about everything all the time. So, as Terence says, be confident and just be honest. If you don't know something, don't make it up or pretend that it is what it isn't. Then people will see through it. But be confident and I like that, Terence. That's really, really, really powerful. Thanks, and good advice, everyone.
So Eric, I don't know if we have any other questions on the chat. Or,
Actually, no. I think you have already answered the first question I had in the chat. How do we replace you in the future? That was a
So
that was
yeah,
a que-
do
that
not
was a
fear, do
question
not
from
fear, do not
Dennis.
fear, do not fear to replace us. Actually, we are so replaceable, you know. Yeah,
Yeah.
Rehab. I think we want to give Rehab the very, very last opportunity before we give our vote of thanks. Over to you, Rehab.
Actually, I wanted to give a vote of thanks and appreciation for myself. And
Sure. Begin
yes, thank you.
replacing me. The succession plan has begun. Over to you, Rehab.
Yeah, I just wanted to
Ladies
say
first.
thank you. This is such a very I learned so much, and even I was able to challenge myself and really ask some really questions that are like above quote unquote my pay grade. And I think this is the process how you learn quickly and efficiently. And even I have some things I'm supposed to go and research and find out more because I have such a curious mind. So thank you, Terence, for your advice, also for telling us to be audacious, to be brave. I think the only way you're ever going to get anywhere in life is you're courageous and you take risks. I think that's the best way to move forward. And also, Gareth and Eric, thank you so much for the talk, for letting us know so much and sparking our interest in the wonderful world of cloud engineering and cloud computing, and also telling us about the security concept, because I think the problem when it comes to us, what people studying IT, sometimes we think of security as a separate aspect. But in the current world we're living of cyber attacks and security threats, security is the baseline, the foundation. It should be applied at every single level. That's the one thing I've learned today, and I'm definitely going to take that home. Thank you guys so much.
Awesome. Absolute pleasure. Thanks, everyone.
Yep.
Have a great rest of day. Thanks, Terence. Thanks, everyone.
Yep. Thank you very much, Gareth. That was really cool. Terence, over to you.
Nothing much from me. I just want to wish all of you a restful weekend, and thank you, Gareth, as usual, for taking some time to minister to our learners. We are very happy, and I also thank you, everybody, for that very engaging participation. I'm happy for the topic selection you made. Thank you, Selina and Janet, for the, you are the shadow of the sun, the immense preparatory work you do together with Jerusia and the rest of Silicon Overdrive to make these sessions possible. And we look forward for the next one. And see you soon. All the best. Bye.
Thank you so much. Cheers. Have a good weekend.